In this section, I want to start configuring my router with BGP. And as I told you at first, I want to put all of these routers into one AS, that is one autonomous system. But what will the number of my autonomous system be? So let's take a look at the numbers that we can assign to our network. And I want to type them here so that I can easily understand them. Let me reduce the size of this font. I cannot select number 0 because this is reserved. Okay, 0 is not usable. I can select 1 through 64,495 if I want to be public, if I want to be routable. So what should I do? I need to contact Yana and reserve one of these autonomous system numbers. And remember that these are gonna be changed. These have, been under changes, and now the number of autonomous systems are not limited to this. As I know, it has slightly been changing, and we have a new format that adds another, range of ASs, and I'm not going to talk about this right now. Let me see this later. So the number 64,496 through 65,511, this is reserved for documentation, so this is not usable again. But what we can use for our internal usage, for our private usage, if we want to have an AS number but we don't want to be routable in internet, we can select this range. I want to add another line here, 64,511 to 65,534. It is a little hard to remember these numbers, and I should have, checked this on internet, but this is what my memory can, help me remind it. Okay, this is for private usage. If I am right, I can select one of these numbers, and the only number that remains here is 65,535. This is again reserved. We cannot use this number. So the actual number that I can select is one of these numbers. And because I want to be very simplistic, I just want to select 65,000 as the autonomous system number that I'm going to use for my network. So I'm going to select AS 65,000 first of all, and later we will choose to change this. Okay, how can I configure this AS number on my routers? I can go to one of my routers, for example router 1, double click on the instance of BGP. Of course, you need to go to routing BGP and double click on this instance. You can see that I have previously changed it to 65,000. I can change the name, and I can add a router ID. Again, you should do this. You should add a router ID, because this is a better idea. So we can redistribute any routing protocol into BGP. I'm going to talk about these later, and I'm going to be very detailed about this in redistribution section. Okay, now click on OK. Now you should decide how you are going to create your neighborship. For the sake of simplicity, first of all, I want to create neighborship between routers that are connected to each other. But as I told you, this is not required. I can create a neighborship between router 1 and router 4, between router 2 and router 3, or any other router that is far from me. But just I want to be very, clear for the first. Let's go to router 1 and select our peers. You can go to peer, click on plus sign, go here, and as you can see, you can select a name, and the name, I just want to put the peer name here. This is easier to remember for me, that this is neighborship between router 1 and router 2. So name is going to be router 2, instance is going to be default. I don't create another instance here. I go to remote address, and this is very important decision that you make. The remote address should be reachable. And I want to make it 10, 10, 12, 102. Okay? The remote AS, again, you should be very careful about the number you enter here. My peer router 2 is in the same AS as I am in. So I type 65,000 here, and I'm not going to change any other option here. Just click on OK. That's it. Now you can see that the status is active. It tries to send some TCP messages, TCP synchronization messages to this neighbor, and it is going to be to the destination port of 179. Actually, BGP creates a connection. BGP connection is on TCP port 179, so the destination port is going to be this, and the source port can be any random number. So let's go to router 2. Router 2 should agree with this neighborship. So close this and go to routing BGP. First of all, I want to change the AS number here. This is going to be 65,000. Again, I should create a router ID. I don't have to, but I should. 2222 is the best router ID that I can assign to this. Click on OK. Go to peers and create a neighborship with router 1. I type router 1. Its remote address is 10, 10, 12, 101, and it is in AS 65,000. These should match. Otherwise, your neighborship will fail. So I click on OK. And after a moment, you can see that this state idle changes to established. And if it is not established, there is a problem with your neighborship. So you should go and change the parameters to make sure that this is working just fine. So I want to show you some more things here. You can see the multi-hop is not, route reflector is not, TTL is the default, and these are the neighborship that I have created. Now I want to create a neighborship between router 2 and router 4, and router 1 and router 3. So let's go to router 2, add another neighbor. This is going to be router 4. The remote address is 444. No, this is not. This is 192.168.24.104. The remote address is, the remote AS is 65,000. That's the only thing that I need to assign here. I click on OK. Let's go to router 4, and router 4 should agree with this neighborship. So first of all, open routing BGP, change the AS number to 65,000, and change router ID to 4444. Click on OK. Go to peers, add a peer. The peer name is going to be R2. The remote address is going to be 102. And the remote AS is going to be 65,000. So everything should match. Click on OK, and after a moment I should see a state of established here. And as I told you, I want to create a neighborship between router 1 and 3. So let's go to router 1, add another peer here. This is going to be R3. The remote address is going to be 10, 10, 13, 103. Our remote AS is going to be 65,000. Click on OK. Let's go to router 3. It should accept the same thing. Routing BGP. I want to expand this. Change the AS number here to 65,000. The router ID is going to be 3333. Click on OK. Go to peer. Click on a plus. And the name of my peer is router 1. So remote address is 10, 10, 13, 101. and the remote AS is 65,000. So this is my neighbor, and okay, and after a moment I should see in a state of established. Okay, now I have BGP neighborship between all my routers, and I just want to show you one more thing. I just want to create neighborship between router 4 and router 3. If I want to do this, I can go to router 3 and click on this peers, and I can add router 4, and the remote address is gonna be one of, for example, addresses that is reachable, and I just want to use its loopback IP address. It doesn't, matter which IP address you choose from the destination router. It should only be reachable. And first of all, I want to make sure that it is reachable. If I go to ping and select to ping 4444, I start the ping and it is working just fine. If I want to have the source of this ping, my loopback interface 3333, I go to advanced and select the source address and start the ping. You can see that again, if I try to ping 4444 from 3333, that's working. So they are reachable, and I can create the neighborship using loopback interfaces. So the remote IP address is going to be 4444. The remote AS is 65,000. But what I am interested in is this. I can go to advanced. As I can see here, there is an update source here. I can select it to be loopback 0, or I can enter the IP address. It doesn't matter which one you do. I just select loopback 0, and as I told you, it is like I am sourcing my BGP session from my loopback 0 to router 4's loopback 0. I click on OK, and let's go to router 4 and select this. Click on peers. This is going to be router 3. The remote IP address is 3333, and I know that it is reachable. Remote AS is 65,000, and if I go to advanced and select the update source, loopback 0 is the source of my neighborship, and after a moment you should see that this is established. Okay, now I have selected one neighbor that is far from me. Actually, to reach the router 4's loopback 0, I need to go from my loopback 0 to the first outgoing interface. I can go to router 1, router 2, and router 4, and after that to loopback interface here. Or the other way is this. I can use this way. I can go to Ethernet 3, go to router 4, and from that go to loopback interfaces. So I have two different ways to reach to router 4. What if this line fails? I can use the other way. I can go this way. If this line fails, my BGP neighborship will not fail, because I have selected my loopback interfaces, and these loopback interfaces actually have two paths to reach to the destination, to reach to each other. So if this line, for example, fails, OSPF, that is my underlying IGP protocol, will reconverge and find another way to reach to this destination, because I have multiple paths to reach to the destination. And whenever that path is in my routing table, my session will reconverge to use that path. This is exactly what I meant by using loopback interfaces here. But if I select to have one of these interfaces, for example, the actual interfaces on my router, they only have one path to each other. And if this link fails, the session will fail. So using loopback interfaces is preferred over using normal interfaces. And one more thing. You should be very careful about this. As you can see, when I am using loopback interface, I am one hop away from the actual interface on my router, and another hop to the destination router, and another hop to this loopback interface. You can see that I need to go several hops to reach to the destination, whichever route I take. In internal BGP, that's okay. The message that is used to, create the neighborship, the message that is sent to the destination router has a TTL of 255 in internal BGP. What if I want to create a neighborship with an external BGP router using loopback interface? For example, if I want to create a neighborship between router 3 in AS65000 and ISP2, for example, in AS2, then I need to go 1 hop, 2 hop, and 3 hops here. When I am doing this, because this is external BGP, BGP changes its behavior to use a TTL of 1. So you can actually create direct neighborship between two routers, unless you want to use the loopback interfaces and change this TTL with a property that is called multi-hop. If I select one of these neighbors, you can see the multi-hop here. If I select multi-hop, the TTL is going to change to 255. And actually, you have a TTL value here that you can select it from default to whatever you want to. But whenever you select multi-hop, you tell the router that the destination router is multiple hops away from me. But as I told you, in internal BGP, you don't care about this. In internal BGP, you have a TTL value of 255, and that's quite okay for your purpose. Now, in next section, what I'm going to do is to create neighborship between ISPs and my routers.